Certainly. Here's a step-by-step explanation of the Java program. 1. Package declaration. The program begins by specifying that it belongs to a package named Java Practical. Packages in Java help organize classes and prevent naming conflicts. 2. Class declaration. A class named printArray is declared. Classes in Java are blueprints for creating objects and contain methods and variables. 3. Main method declaration. The main method is defined as the entry point of the program. This is where the execution of the program begins. 4. Array initialization. An array of integers is created and initialized with specific values. Arrays are used to store multiple values in a single variable. 5. For loop. A for loop is used to iterate over the elements of the array. The loop runs from the first element, index 0, to the last element, index equal to the length of the array minus 1. 6. Printing elements. Inside the loop, each element of the array is printed to the console. The println method is used to print the elements, which outputs each element on a new line. 7. End of program. The program ends after all the elements of the array have been printed. In summary, the program initializes an array with specific values, then iterates through the array and prints each value to the console. The main method acts as the entry point and orchestrates the flow of the program. Array initialization. An array of integers named ARR is created and initialized with the values 21, 3, 53, and 64. Arrays are used to store multiple values in a single variable. Variable initialization. A variable min is initialized with the first element of the array. This variable will be used to keep track of the minimum value found in the array. For loop. A for loop is used to iterate over the elements of the array. The loop starts from the first element and goes through each element of the array. Finding the minimum value. Inside the loop, an if statement checks if the current element is smaller than the current value of min. If a smaller element is found, min is updated to this new value. A message is printed to the console each time a new minimum value is found, displaying the current minimum value. End of program. The program continues until all elements of the array have been checked. The final minimum value is the smallest element in the array. Summary. The program initializes an array with specific integer values. It initializes a variable min to the first element of the array. It uses a for loop to iterate through each element of the array. During each iteration, it checks if the current element is smaller than the value stored in min. If a smaller value is found, it updates min and prints the new minimum value to the console. The program effectively finds and prints the minimum value from the array. Initialize array. Create an array ARR with values 21, 91, 53, 64. Set initial max. Start with the first element of the array as max. Iterate array. Loop through each element of the array. Update max. If the current element is greater than max, update max. Print result. After the loop, print max with an incorrect label minimum element from array. Correction needed. The label should be maximum element from array. Initialize array. Create an integer array ARR with values 21, 3, 53, and 64. Sort array. Use arrays.sort ARR to sort the array in ascending order. Print header. Output the text list of sorted array to indicate the beginning of the sorted list. Iterate and print. Use an enhanced for loop to print each element of the sorted array, followed by a comma. Output format. Elements are printed with a comma following each value, but the last element will also be followed by a comma. Initialize array. An integer array ARR is created and initialized with the values 78, 34, 1, 3, 90, 34, -1, -4, 6, 55, 20, -65. Print header. The line system.out.println array elements after sorting outputs a message to indicate that the following output will be the sorted array elements. Sorting logic. The outer for loop iterates through each element of the array with index I. Inner loop for comparison. The inner for loop compares the current element, ARR, A, with the subsequent elements, ARR, J. Swapping elements. If the current element ARR, I, is greater than ARR, J, the elements are swapped. A temporary variable TMP is used to hold the value during the swap. Print sorted array. After each pass of the outer loop, the current element ARR, I, is printed followed by a comma. Formatting issue. The print statement within the outer loop will include a trailing comma after the last element, which might not be desired. Initialize array. Create an array ARR with values 1, 2, 3, 4, 5, 3, 1. Create hash set. Initialize a hash set named scene to keep track of unique elements. Loop through array. Iterate over each element number in the array ARR. Check for duplicates. Use scene.contains number to check if the element number is already in the hash set. Print duplicate. If the element is a duplicate, print it using system.out.println duplicate found plus number. Add to hash set. Add the element to scene if it's not a duplicate. Initialize array. Create an array ARR with values 0, 1, 0, 3, 12. Set non-zero index. Initialize non-zero index to 0. This will track where the next non-zero element should be placed. Move non-zero elements. Iterate through the array, placing each non-zero element at the non-zero index and incrementing non-zero index. Fill zeros. After moving all non-zero elements, fill the remaining positions in the array with zeros. Print result. Display the modified array using arrays.toString, ARR. Initialize array. Create an array ARR with values 1, 2, 3, 4, 5. Set pointers. Initialize left to 0, start, and right to ARR length, 1, end. Reverse array. Swap elements at left and right indices, then move left pointer to the right and right pointer to the left. Repeat until left is no longer less than right. Print result. Output the reversed array using arrays.toString, ARR.